Greetings there, and welcome to James tutorial. Today we'll be covering Newton's laws, so grade 11 and grade 12s, this is for you. Please do leave your comments in the comment section to let us know how we should improve as to how we conduct these lessons. Please share the link to the video if you find it helpful after watching it. So we are just going to start ahead. So let's start with the first law, or rather inertia. It's the same thing. I don't have space there, but it's inertia, guys. Inertia is the same thing as Newton's first law. There's a question that usually comes up in the multiple choice questions that Newton's law is the same as, so you need to look out for the word inertia. So what Newton's first law states is that the body will remain in its state of rest or continue traveling at a constant velocity unless an unbalanced net force acts on it. So what this means is, if let's say maybe we are having an object there, and there's a guy maybe standing over there who's trying to push, let's say he's pushing this box to that direction. Newton's first law states that the box will try to resist the change. It will not want to move. It was at rest, to mean that its velocity is 0. It will not want to move, guys. It will remain at rest. If, for say, it was moving at a velocity of, let's say, 5 meters per second to the left, and you suddenly want to apply a force to increase its speed, I was thinking maybe we will start by introducing the forces, because some people may have difficulties, or rather we'll do it after this first law. So the box will try to resist change. If it was at rest, it will resist being changed, because when the man is pushing the box, for sure it will move, but it will first resist. That's what inertia is. If it was moving at 5 meters per second to the left, it will resist the change, because if the man pushes with a force to the left, the object will increase its velocity. We'll come to that just now. Let me just remove this. I want us to first talk about forces, because Newton's laws are all about forces, guys. Let's talk about forces, guys. What is a force? I'm sure you are all shouting because we learned it in grade 9. We said a force was a push or a pull. So it stays like that. Whether you apply a force trying to pull something towards you, it's a force. If you are pushing something, it's a force. Now, one other thing you learned, guys, is that when a force is applied, it will change the state of the object. It will change the velocity of the object. whether slowing it down or increasing its velocity. Now I want us to talk about different types of forces, because these are the basics of Newton's laws, guys. If you understand all the forces, you will not be having problems in answering Newton's laws. So let's first talk about tension. Tension, which is denoted by capital letter T. So what is a tension force, guys? A tension force is a force that exists between a string. Say for instance, we are having two boxes which are connected by a string. It will always be inextensible. Forgive my bad drawing. So let's say maybe the boxes are moving to the right. I'm not going to put a label on the magnitude of the mass of the boxes. Let's say the boxes are moving to the right. So a tension force, I said, it is a force that exists when there is a string or a cord or rather a thread, anything that is rope like. Others may be familiar with the word rope, but on the question papers it is denoted as a string, inextensible string. So let's say these boxes are moving to the right, are moved by a certain force which we are not particularly interested now. So what will happen is that the small box, or let me say it's 4 kg, and this one is 6 kg. So the force that will act on the 4 kg as it is moving to the right, if you see there's a load, it is carrying a load, or rather it is pulling the 6 kg block. So the force that is exerted in order to pull that 6 kg block is a tension, and it is exerted by a 6 kg. So if you are saying it is exerted by a 6 kg, as the 4 kg is moving to the right, the 6 kg is applying a tension force to it and trying to move it backwards. So I wanted to give you the idea that the tension force acting on the 4 kg is to the left. Let's come to the 6 kg block. If the 6 kg block is moving to the right, yes, it is moving to the right, but the thing that will happen is that the 4 kg block will also exert a force through the string, because it is attached to the 6 kg block. It will try to drag the 6 kg block to the right. So the tension force is acting to the right on the 6 kg because it is moving to the right, guys. I'll go through over it again. The tension force acting on the 4 kg arises from that it is pulling a mass behind it. So it is the 6 kg is pulling the 4 kg with a tension force through the string backwards, that is to the left, while the 6 kg is moving, it is pulled by a string. The string has a tension force that is to the right. So that's it for the tension force. In order for you to memorize it or cram it, you just need to first determine the direction the box is moving in. The one on forward, we will be pulled backwards by the one on the back, and the mass on the back is pulled forward by the one in front. But if you had my explanation earlier. I think it is now clear. Coming to the second force we will have to talk about is the force applied, or rather applied force. I'm just going to say APP. What is a force applied, guys? A force applied is self-explanatory. A force applied is any force you apply. Going back to my earlier example, I said if we had a box here and a man was standing there trying to push a box. Remember, a force is a push or a pull. If you are having a man there trying to push a box towards that direction, let's say he has a long arm there, he's trying to push, it's a force applied because he's applying a force, he's pushing, he wants something to happen when he's pushing the force. Or if we had a string there, let me not use a string, it will confuse you, but if we had someone standing over there pulling the box towards his direction, that's a pull, guys, that's a force applied. It is very easy to identify. Moving to the next force, your next force we are going to talk about will be your frictional force, guys. Frictional force. What is a frictional force? I'm just going to say frictional F there. Now, what is a frictional force? A frictional force is the force that opposes the tendency of a moving object, guys. It always opposes the direction of an object. So if you are having, say, maybe let's say a car, if you are having a car and is moving at that direction, you'll notice that the wheels of the car do not stay the same all the time. They tend to age, or rather become damaged. The thing that damages it is the frictional force offered by the surface. The frictional force is the force that is exerted by the surface with which an object is in contact with. So if this object is moving on this road, the frictional force will be offered by that road surface. So if it is moving to the right, the frictional force will always act to the left. Remember, I said it is the force that opposes the tendency of a moving object. So the frictional force will always be opposite the direction with which the object is moving. So if an object is moving, let's say it is reversing now, it is going that direction, the frictional force will act in which direction, guys? It will act in that direction. So if maybe an object is moving upwards, the frictional force will act in which direction, guys? Downwards. It's always opposite the direction of motion or direction of movement. Now we have two types of frictional forces. The first one being the static frictional force, which I will only denote with Fs, guys, the static frictional force. Now, what is a static frictional force? A static frictional force is the frictional force that is experienced by a stationary object. Static from derived from the word stationary to mean that it is not moving, its velocity is 0. So So let me first write a formula for calculating the maximum, it's max there, the maximum static frictional force. So say for instance you are having an object there, and that man we talked about, we said the guy had long arms, let's say it's 4 kg. The guy is trying to push, that is trying to apply a force to the stationary object to move to the right, to the left. The guy is trying to move the object to the left. Now the object is not moving. It's not that the guy is not exerting a force, but there is that frictional force we are talking about now, the static frictional force. At some point the object will have to move. Say for instance it was a small boy moving a 4 kg block. Maybe he will not be able to move the box. Let's say maybe he cried and called his father and told him to move the box for him. Now I want to come to the concept of the maximum static frictional force. So let's say the guy called his father, let's make him big. So the father is definitely having more power than his son, so he's definitely going to move the object. So guys, I want to ask a question which you will not necessarily answer, but I want you to get the idea. Why was the object not moving when the son was still pushing the box? It's because of that static frictional force. Now let's come to the concept of the maximum static frictional force. What is the maximum static frictional force? It is that frictional force, the maximum that the surface with which the object is in contact with offers. It is the maximum. Say for instance, if the boy was exerting 4 newtons and the maximum frictional force of the object was 6 newtons, the object would not move. In order for the object to move, a person has to exert a force which is greater than the maximum static frictional force. How to calculate the maximum static frictional force? I wrote that formula there. It is Fs max. I'll write it again just now. It is Fs max equals to mu s multiplied by normal force. What is this mu s that I've been talking about? It is the coefficient of static frictional force. You will be given this information in the question you are required to answer, and the normal force will come to the normal force just now. So I wanted you to have an idea of how to calculate this maximum static frictional force. Coming to the second type of a frictional force. I'm sure you guys are already shouting there, saying you know what is the next force we are going to be talking about. It is the kinetic frictional force, denoted as Fk. Now what is this kinetic frictional force we are talking about? Remember, we said as the guy applies a force on the object, it will have to move at some point. Now we said the frictional force is a force applied to a moving object in the opposite direction. Please guys, go to the examination guidelines for correct and acceptable definitions. I'm just going to state them as I remember them. So any moving object has a kinetic frictional force. Kinetic to mean that it is moving. Remember, in static frictional force we said static to mean that it is stationary, kinetic now to mean it is moving. So there's a formula of calculating Fk. It's mu k multiplied by the normal force. So these are the equations we are going to be using, and you have to familiarize yourself with them. The mu k, you are also going to be given the normal force. We'll come to that just now, but there's a question that crosses my mind that usually appears on a question paper. This question usually asks, why does the coefficient of kinetic frictional force does not have units, SI units of measurements? One thing that I forgot, guys, which is most important in physical sciences, is to always write your answer with the correct units, guys, the correct SI units, because sometimes the examiners can be very harsh and do not award you marks if you do not write the SI units with your answer. So I'm just going to write that formula again. Remember, I've just said a force is measured in newtons. A force is measured in newtons. So I think you could all agree with me that the kinetic friction is a force to mean that its SI units are in newtons. The normal, which we are going to be talking about, but it is a normal force. If it is a force, guys, it is also measured in newtons. So I'm only writing SI units here. So imagine if you were to solve for the coefficient of kinetic friction, being given the kinetic frictional force and the normal force. At some point you will have to divide by the normal force, and what you do on the left hand side you do on the right, so that you are left with what? The coefficient of kinetic friction, which we are looking for. So the SI units for the frictional force, which are in newtons, are going to cancel out with the newtons for the normal force. So this is the reason why, guys, the coefficient of kinetic friction does not have what? SI units. So to be more correct when you state it, is that the coefficient of kinetic friction is a ratio of forces. You can be specific if you like, is a ratio of a kinetic friction and the normal force. Maybe you can go further to explain that the newtons cancel out, but you can put simply as that. Coming now, guys, to the normal force I've been talking about. What is a normal force? A normal force is a force exerted. It is denoted by capital letter N, which is the same as newtons. It is the force exerted by a surface with which an object is in contact with and acts perpendicular. So let's say, for instance, we are having a table there. Let's say we are having a table, and on top of it sits a box, or rather rests a box. let's say, rests a box, and I don't know what we are going to call that, but I just want to put some objects on top of this table. So we are saying normal force is a force exerted by the surface with which an object is in contact with. So in this case, guys, the normal force is exerted by what? By the surface of this table. So we are saying it acts perpendicular to the object. So you could see that these objects are resting horizontally perpendicular, to mean that the angle between the surface and this force is what? Is 90 degrees. So in order to have 90 degrees, there would have to be something like that. There is my 90 degrees. So any object resting on a surface, be it is inclined or horizontal, but there is what? There is normal force. If you are having an object resting on an inclined, there is a normal force because it is on a surface. It is on a surface, guys, be it is a hill or whatever. So we are saying this force acts perpendicular. The mistake that most learners tend to make is that they look at one particular problem and memorize that the normal force was going upwards. There we are saying it acts perpendicular, so you could see that the surface is inclined. So in what direction should the normal force act in order to form 90 degrees between it and the surface? It should act on that direction, guys. There is that 90 degrees we are talking about. 90 degrees. So you need to be very careful. If a surface is resting on a surface like this, the normal force would be acting in this direction in order to make that 90 degrees. So once more, we are saying a normal force is a force exerted by a surface with which it is in contact with and acts perpendicular to the surface. Again, guys, please go on and read correct definitions according to the examination guidelines. Coming to the foremost and important force that you guys should never forget, that is the gravitational force. I don't have space, but it's gravitational force. All the forces, guys, are measured in newtons. What is gravitational force? It is usually denoted as capital letter F, G, or simply as W. That is the weight, guys. Now, what is the gravitational force? It is the force that is exerted by Earth's surface, guys. Sorry, it is the force exerted by the Earth on the objects on or near its surface. So be it the object is how many meters above Earth's surface, it will always experience gravitational force, or be it the object is in contact with Earth's surface, it will always experience gravitational force. Now we will find gravitational force on every object, guys. In every object you will find gravitational force, and this force always tends to pull the forces downwards, and that's the good thing about it. You don't have to think in an exam when you are asked to write a free body diagram as to in which direction is this force going to. This force always acts downwards, vertically downwards. So if an object has a mass, say for instance it is 5 grams, 5 kilograms, whatever, but it will always have this force. Please guys, do not forget this one, but I'm hoping everyone is clear about the gravitational force. Now what I want us to talk about here in the gravitational force is the is when you are faced with a question that has inclined surfaces. Okay, rather let's talk about first the components of gravitational force. So I'm just going to denote this one as Fg parallel, that is the parallel component of gravitational force. You don't have to to mistake these two components. They are very different, guys. The parallel component of the gravitational force will always act parallel to the surface. You will find the components of gravitational force on an inclined surface. So if you are having a surface inclined like this, whether an object is moving upwards or downwards, but this parallel component of the weight will always be directed downwards and parallel, guys, parallel. So this force will go in this direction. This is your Fg parallel. If you are having a surface inclined in this direction, remember it is always directed downwards since it is gravity, but since it is Fg parallel, it must be parallel to the surface, guys. This is Fg parallel, the parallel component of the force. If you have been wondering if maybe you were to place an object on a slope or maybe on a hill, and maybe sometime you would see that it is rolling down the inclined surface while nothing touched it or no one applied a force. It is the parallel component of the weight that is responsible for the movement of that object. So the equation we are using to calculate the parallel component of the weight is mg sine theta, m being the mass measured in kilograms, guys. G, this is a constant G, which is always 9,8. It is always there. And what is this theta here? It will always be an angle between the incline and the horizontal. So if you are having, I'm just going to write here at the top, if you are having a surface that is inclined in that direction and there an angle between it and the horizontal, let's say maybe it is 30 degrees. Always, guys, do not make this mistake, because in physical sciences you get easy marks for substitution. So by writing 30 degrees there and substituting the mass, you'll definitely get marks, and writing that 9,8 there. I hope it is clear. Moving to the perpendicular component of the weight. The perpendicular component of the weight, guys, always also acts perpendicular to the what? To the surface of the incline, guys, same as what? As the normal force. So for instance, if we are having an object resting there and we want to know what is the perpendicular component, remember it is the component of the weight, so it should be directed downwards. But now, since it is the perpendicular component, it should be perpendicular to the what? To the surface. Is downwards in that direction, guys? No. Could it be in that direction? No, because this force is parallel to the surface. Rather, it should be perpendicular. So perpendicular would be in that direction and directed downwards. So this is your FG, perpendicular, capital letter F there. So we are going to write some free body diagrams today, so we'll come to it. Don't worry, if you don't have a clear understanding, you can pause the video, go back, listen carefully. We'll be done when everyone is clear. So there's one other thing I want to come to. Let's first talk about an object resting horizontal, or rather, let's not say resting, but on a horizontal table. Let's say that one is 4 kg. So let's say maybe let's connect it to another object, guys. Let's make this one small and say it is 2 kg, and let's say there is another string. Let's call this string, let's say Q, and let's call that string P. So guys, if you were asked to draw a free body diagram of the 4 kg mass, first let me explain what a free body diagram is. It is a diagram which shows the forces acting on an object. What is a force diagram? It is the representation of an object with a box showing all the forces acts on it. So the difference between a free body diagram and a force diagram is that in a force diagram you draw the exact object and show the forces acting on it, but rather on a free body diagram you represent the object with a dot. So it's more or less the same thing, guys. So if we were first having to write or label forces acting on the 4 kg without even hearing what is happening here, there's a force that I said must always be there. We said this is a table, so you can say that the 4 kg is resting on a table and the 2 kg, and there's a string. So we are already thinking about the forces we already mentioned that could exist or act on these objects. The first force, guys, you must not forget that you must always start with is the gravitational force, and we said it is directed downwards. So there it will be in that direction. So I'm just going to write FG. The way to not forget it is that it is denoted as FG. That G, that is by God, it will always be there, guys. It will always the other forces may not exist on an object, by the force of gravity will always be there. You always have to start with it. What is another force we are thinking of? Because I said the 4 kg is resting on a surface, you are probably thinking of what? Of the normal force, guys, because we said a normal force is a force exerted by the surface with which the object is in contact with and acts perpendicular to the object. So the normal force on the 4 kg will definitely act upwards because it is a force exerted by the surface on this object. Now let's extend our statement. Let's say there's a man who's pulling string P, which is this string here, to the left. So the objects, the 4 kg and the 2 kg objects start to move to the left, guys. So what other forces can you identify from this statement? What other forces can you identify? You would definitely note that there is a force that is applied, that is a pulling force. It is not tension force, guys. P is not a tension force, or rather a force that is acting on P is not a tension force, but it is the applied force. Some may call it an applied force, sorry, a tension force, because it is the force acting on a string. But if on a statement you were given that a certain force was pulled with to move the objects, you could say it was a force applied. It will be accepted to say it is also a tension force. So let's say that force P is a force applied. I'm just going to use it as a force applied. What other force can you identify, guys? Remember, where there is a string, there is what? There is a tension force. So on that 4 kg, the 4 kg is moving to the left. You could see that it is dragging the 2 kg. So in which direction is the tension acting on that 4 kg? Remember, I said the object in front will be pulled in the opposite direction, guys, in the opposite direction. So the tension force would act on that direction, that is to the right. So if I further extended my statement and said the surface with which the objects are resting is rough. These are the keywords, guys, you have to be careful of. If they say the surface is rough, it's to mean there is frictional force. And what type of frictional force will you find there? Because I said the objects were moving, it's definitely what? The kinetic frictional force. And what did we say about the frictional force? We said it is the force that opposes the tendency of a moving object relative to a surface and acts perpendicular. So if the object is moving to the right, the frictional force would act to the left. In this case, the 4 kg is moving to the left, so the frictional force will act in that direction. So I was trying to show a force diagram, but I can see it is messy, so I'm just going to move to a free body diagram. So if you were instructed to draw for a free body diagram, it is best to start with a force diagram. So in a free body diagram, we said let me first make some space here. You would first have to make a dot. I would advise that you make your dot bigger so that it can cater all the forces. So I'm just going to draw the force. Forgive me for this clumsiness. I'm just going to draw the first force that I said we must note, the force of gravity, guys, and I'm just going to denote it as W for weight. The second force that we identified was the force which is exerted by the surface on the object, which is the normal force. Another force we identified was the force applied in this case. Another one was, first it was tension, because we saw the string. The reason why I say you must make your dot bigger, it's to cater for all the forces. So the first one was tension. Sorry, the fourth one, what is another one? We identified frictional force, guys. I'm just going to make it FK. So we'll make yours using a ruler. Forgive mine, it is very clumsy. So if you guys can see this, there's nothing difficult. You first have to make a force diagram to identify all the forces, starting with the gravitational force, of course. And then after finishing with your force diagram, it is very easy to move to your free body diagram. So if you are very comfortable with drawing of free body diagrams, you are not going to have trouble when we come to Newton's second law, which we will in the moments to come. Let me not say in the few minutes to come. So I want us to come to that 2 kg. So if you were told to draw a free body diagram of that 2 kg, so you will first have to identify all the forces. Remember, you must start with your force diagram. Which force do we write first, guys? It is the force of gravity, which always acts downwards. What is another force we identify? It is the normal force, because that 2 kg is not moving on air, but rather is moving on top of an object, sorry, on a surface. So I said earlier that the surface was rough, to mean that there is friction. Remember, this object is moving in that direction. So what direction will friction act? It will act in the opposite direction, guys. What is another force? There is a string there. So if there is string, what force could be present there? I'm sure you are all shouting that it is tension acting to that direction. Now let's come to draw the free body diagram. Make a big dot there and just copy and paste from your first diagram. We drew the force of gravity, identified the normal force, identified the frictional force. You can just write as FF or as FK to show that you understand that it is the kinetic frictional force. What is another force? It's tension, guys. So if you are comfortable with drawing free body diagrams, as I've said, you will not have any difficulties when it comes to Newton's second law and that. So I'm just going to go to inclined surfaces so we can draw maybe a free body diagram there. So let's say maybe you are having a surface that is inclined, and maybe let's put a string there. Please, guys, be careful, be able to read and analyze your statement, because as there is this force which is applied, it does not necessarily mean the object has to move upwards, guys. Be careful when you are reading your statements, because a force applied can be less than the kinetic frictional force. So the object would, sorry, not the kinetic frictional force, but the parallel or the gravitational force. It is possible for a force to be applied upwards and an object to move downwards. So let's say in our case this object is moving upwards, so there's a force applied there, and the object is moving upwards. Which force would you identify first, guys? Always, because there is an object, there is a force that we said it is always directed downwards, guys. It is directed downwards. And which force is that? It's Fg. And coming to this force that is very visible, this force that is applied through a string, in your statement, guys, the force, the reason why I'm saying this may be a force applied or a tension. On a statement, it could be said that a 20 newtons force is applied on the string, or rather not on a string. A 20 newtons force is applied to move the object upwards. So you can call it tension, but you must be able to identify the magnitude when given. So to show you that it's the same thing, this time we are going to call this force tension because there is a string, so there's tension there. If the surface there is rough, guys, I'm trying to say there is what? There is friction. So which direction can friction act on this object? Remember, it always opposes the motion of an object, so it should act opposite the direction of motion, that is in this direction. So I'm just going to say it's Fk to show that I know it is a what? It is a kinetic frictional force. What is another force we can identify, guys? Remember, this object is not moving on air, or rather it is moving on top of a surface. So the surface will exert a force. In which direction can normal force act? Remember, it always has to act perpendicular to the surface. This time it will not go up because our surface is not horizontal. So it is acting on this direction perpendicular to the surface. So that is normal force. Now, earlier we talked about the components of what? Of gravity. Guys, you cannot draw the components of gravity and gravitational force itself because there's an equation that is true, that Fg parallel plus Fg perpendicular equates to the Fg. So these are components of that Fg. So if you add these together, you should get what? The gravitational force. So if you want to draw a gravitational force directed downwards, you should draw it. If you want to draw the components, you must draw them, but exclude the what? The gravitational force. So if we were to draw the the components of this force and cut out this force, in which direction would first the perpendicular component of gravity act? Remember, guys, we said it is the perpendicular component, and to mean it must act perpendicular to what? To the surface. So perpendicular to the surface is either in that direction or in that direction. It is gravitational force, guys, so it has to act downwards, so it is in this direction. So this is the perpendicular component. It's already clumsy here. This is the perpendicular component of gravity. It's in this direction. Oh, one other thing I forgot, but I will touch it after this. So if you were to draw the parallel component of gravity, in which direction? Remember, guys, we are saying it is the parallel component of weight or of gravity. it should be directed downwards. Parallel, it should be parallel to the surface of the incline. So parallel to the surface of the incline is anything in this direction, but because it is gravity, it should be directed downwards, guys. So if I were to draw the free body diagram first with I'm just going to make space here. Okay, I'll just redraw it. There was something I wanted to talk about. So if we were to draw the free body diagram first, with no components of weight, you will be having Fg there, your normal force, your tension, and your friction there, Fk. So your free body diagram will be something like this, but it will be much beautifuler than mine because we will be using a rule. I'm only using a free hand here. So if you did not want to draw the gravitational force itself, we'll draw the components of gravity. So we said the Fg perpendicular will be in that direction, and the parallel will be in the same direction as what? As friction. Now coming to what I wanted to say, guys, there is a formula I forgot to write when I was talking about the normal force. Maybe it's because there is no particular formula for a normal force, guys. You see, if an object moves horizontally and does not move vertically, if it is laid on a horizontal table, say like this, and the object moves either to the left or to the right, it does not mean there are no vertical forces acting on it. It simply means the vertical forces acting are balanced, guys. So if this object was resting there, we know there is normal force there, we know there is what? There is gravitational force there. So you could see that there are forces acting vertically, but the object only moves downwards. What does this tell you? It tells you that the vertical forces are balanced but in the opposite direction. So this means in sorry, in a horizontally placed object, the normal force equates to what? To the gravitational force. What does the gravitational force equal to? Fg equals to mg. Sorry guys, I don't have space. Mg equals to mg. What is this m? It is the mass measured in what? In kilograms. What is this g? It is the gravitational constant, which is always 9,8, guys. So I hope you got that. If an object is placed horizontally, it will always equate to the force of gravity, given that there is no force acting on an angle. So what will how would you calculate the normal force when an object is placed on an incline? So you don't notice that when an object is placed on an inclined plane, it will move either to this direction or to this direction. It will never move in any of this direction, guys. So what does this tell you? It means that forces that are acting in this direction are what? Are equal. Which force did we say acts in this direction? We said it was normal force. Which force did we say it acts in this direction? We said it was Fg. perpendicular. So for an incline, the normal force on an incline, the normal force equates to what? To the perpendicular component of the weight. I'm just making space here. Seems like I've cleared my heading also. So we are saying on an incline, the normal force equates to what? To the perpendicular component of the weight. What did we say? FG perpendicular equates to, if we did not talk about it, it equates to mg cos of theta. M being the mass, G being that constant, and cos being cos theta, being that angle between the horizontal and the incline. You will be given that angle, guys. You'll be given that angle. Okay. I want us to move to something else before we break. I want us to move to something else, that is talking about the components of the forces. Let me just draw a scenario here. Say for instance we are having a force acting on that object acting at an angle theta. So we will see when we come to Newton's second law that there is an equation which is written as F net is equal to ma, which we are not going to talk about now, but that equation caters for forces which are either acting vertically or horizontally. We do not cater for forces which are acting at an angle. So what would happen in order for you to continue using that equation F net equals to ma, you would have to resolve this force to its vertical component and its horizontal component. So in order to destroy that, you'd have to have the horizontal component of the force and the vertical component of the force. Let's start with the horizontal component of the force, which I'm going to denote as Fx. So the equation for Fx is given as F cos of theta. F being the magnitude of the force acting at an angle. So let's say if someone is exerting a force of 20 newtons at an angle of 30 degrees, that force of that magnitude, you will have to substitute here on F. And what is theta there? Theta will always be the angle will be given, that is the angle between the force acting at an angle and the horizontal. So if it was 30 degrees, then in order to have the horizontal component of the force, you would have what? To substitute that angle there. Coming to the vertical component of the force, which I will denote as Fy, it is calculated as F sine of theta. There's nothing, the F there is the same as that one. It is that force which acts at an angle. The theta there is the angle between the horizontal and the force. So if guys you practice these things, you will not have much problem when we come to Newton's second law, third law, and Newton's law of universal of gravitation on our next video. So There was something I was thinking. I'm not sure, but I will put it on the next video. So this is it from us, guys. I hope you enjoyed our lesson. Please do leave your questions on the comment section and tell us what you didn't like maybe about our video. This is it, guys. So goodbye, see you next time.